Can you see my screen?
Yeah.
All right. So let's start. I'm gonna just remind you what we did last time in just yesterday. Okay. Um, Mainly we discuss we can write our derivative of a function. This is like a definition. Okay, so this is the definition of the derivative. You can write it as a limit. Limit which goes to different. Make it little. Limit when h goes to 0, fx plus h minus fx over h. So this is what we call, this part is just the different quotient. If you take the limit of the different quotient, you will get the derivative. Okay, so that's what we learn first, and then we start section 3.3. And here we discuss how to get the derivative of x to the power 2, which is the derivative, you can remember it is 2x. And also we discuss when fx equal to square root of x, you found the derivative as 1 over 2 square root of x. Okay, so in section 3.3, at the beginning of the section we said, okay, if you use this method to find the limit, it's really difficult and it takes time. So we have something called differentiation rules. Okay, so that's what we're gonna start with. So this is called differentiation rule. Differentiation rules. So as a first rule, we talk about, if you have a constant, if your function is a constant, let's say 5, so this is the rule number 1, or you can just say rule number 0. If you take the derivative for a constant function, it's always 0. Okay, so for an example, if your function is equal to k, by what I mean is just a constant. K can be any number. Okay, if it is any number, so derivative of that function is always 0. Okay, and next we start talking about power rule. Okay, rule number 1, it's a power rule. Okay, power rule. In power rule, we learn a most important formula for the derivative, which is if you have x to the power n, n can be any number. N can be half, n can be 100 or whatever. If you take the derivative of the function x to the power n, you will get n down, and you subtract the one from this power and you write it here. Okay, so this is very important formula. Okay, for an example, if I remind you how to do this one, you did this with a long calculation, but now if I ask you what is the derivative of square root of x, which is square root mean half power, you can apply this rule and you can say, okay, you take this half, which is the power, down, and x, and you subtract 1 from half. Is it clear, Pedro?
Yes.
Okay, so you get half x. To do this calculation, it's minus half. Then you get 1 over, you can make this minus plus by taking it down. Okay, then you see, yeah, we got the same answer, which is 2 square root of x, because this is just a square root of x, which is the same answer we got. Okay, So we don't need to do a lot of calculation. We don't need to use this definition since we know the power rule. Okay, so at least if you have a question with which you can apply power rule, apply it. Do not use the definition unless I ask you to do. Okay, so most of the time you can apply the rules directly, right? Next part. Okay, so this is where we stop. So today, so I'm gonna tell you some more details. One more thing I think you remember, if you have a function of fx, let's say x to the power 3, you know how to get the derivative of this function. 3, you take the power down and subtract 1 from the power and you write it here. Sometimes this f dash x people write as a d over dx, and the function you want to differentiate. Okay, so this is the one you need to differentiate. You put it here. Okay, so this is exactly the same as our answer we had here. So this is d over dx is like a derivative function. Okay, derivative or differentiate. So both name are used simultaneously, derivative or differentiation. So both are synonyms. Okay, so this is just an operator like a function. If you want to differentiate x to the power 6, you put x to the power 6 here. If you want to differentiate x to the power 8, you put x to the power 8 here. That's it. Okay, it's another notation. And next thing I want to tell you, a derivative sum rule. Okay, so derivative or differentiation of sum rule. Sum mean you add something. Okay, it's not a difficult thing. It's fairly obvious. So let me write down it. If u and v are differentiable function, you can write down with me if you want. Differentiable functions of x. So what this statement says, you have one function u and another function v. Both you can differentiate with respect to x. So which means these two functions you can differentiate. Differentiable mean you can differentiate. Okay, you can differentiate this function. So if you can differentiate these two functions, let's say your function is like a u plus v, the sum of the two functions. Then if you both you can differentiate. So if you differentiate, you will get the differentiation of u, which is u dash, you can say, and differentiation of v is v dash. So plus remains same. So if you have plus here, you got plus here. And similarly, you can think of a subtraction rule, which is minus and minus. Okay, so for an example, not a difficult thing. So let's say your function is not just x to the power 2, but let's say another x to the power 3 also added. Then it's very obvious or natural. You think, okay, how do you take the derivative? You take the derivative of this, which is 2x, and the derivative of this, which is 3x to the power 2. Okay, so you take the derivative of the both functions separately. Okay, I think AJ joined right now. No, right? So is he doing joined or not?
Yeah.
Oh, you joined? Okay. So
Can you hear me?
yeah, I can hear you. Right. So you can see my screen, right? So we will discuss AJ. We start 3.3. We talk about the power rule. That's the most important rule we discuss. Okay. So if you have a function with the power, let's say x to the power n, then you can take the derivative. We call differentiation. You take the power down and subtract 1 from the power. Okay, so I will continue explaining those things. Please let me know if you need more, if you miss anything, or I can quickly review, or just remind you what we did. Okay, another example. So let's say you have a function, let's say fx equal x to the power 3, x to the power 2, 5x minus 3. So this is my function. I need to differentiate this. So I need to differentiate or take the derivative of fx. I need to take the derivative of fx. So derivative you symbol as dash of prime, f prime. Okay, now you differentiate each term one at a time. So how do you take the derivative of this? You take the power down and subtract 1 from the power. If you subtract 1 from 3, you get 2. So then you are done with this part and you go to the next one. So Pedro, can you tell me what is the derivative of this?
2x.
2x, because you take the power down, and if you subtract 1 from 2, you get just 1, because 2 minus 1 is 1. We usually not write the power if you get 1. Okay, if you think about this one, if you have a constant multiply with that x, just write the constant out. You are taking it out. You totally think, I mean, you take it out like a bracket. You are taking something out of the bracket. So likewise, you just not consider that 5. You just take it out and think about this x. Okay, you only think about the variable that attach with the constant. Constant remain as it is, and you think about x. So x is just, you have power 1. If you take the derivative, this power come down, which is 1 x. And if you subtract 1 from 1, what you get? 0. So this is what? 1. Is it clear? Is it clear,
Yes.
Pedro? Yes.
Yeah.
Yeah, AJ. So if I explain you, remember, if you have, let's say, let me explain like this: x to the power n. If you take the derivative, this is the formula, n x n minus 1. So let me put, because this time I have just x, I am looking for derivative of x. So derivative of x mean I need to make this n equal 1. So it's just 1. Okay, so let me erase it and make it 1. Okay, maybe, yeah, let me see, I can erase it or not. Okay, I erase it. So now I have just 1 for n. So this become 1, because n is 1, x. When n become 1, I have 0. So if you have 0th power, you get always 1. Okay, that's how I get the derivative of x is 1. So remember, if you have derivative of x is 1, and lastly the constant. If you have a constant, derivative of constant is always 0. So the final answer is 3x to the power 2, 2x plus 5. So this is the derivative of original function. Okay, right. So we are still using the power rule. Note, so there's one note I want to tell you. Remember, I told you we can use this notation if you are taking derivative. For example, if you want to take the derivative of, let's say, x to the power 5, you can use this symbol. This symbol says, okay, take the derivative of x to the power 5. How do you take it? You take the 5 down and subtract 1 from the power, and you write it. So that is your derivative. People usually write it as a dash as well. Okay. Let me see. Okay. So this is the derivative of the original function x to the power 4. So both method we can use. So remind that I told you the derivative of x equal 1. So it means you just put x here. You see, if you have dx over dx is just 1. It makes sense if you write like this. You see, if you put x dx over dx, you mean it's the same thing in the top and bottom. So it's just 1. Okay. So this notation much more convenient to see it. Why the derivative of x is just 1. Okay, so that's the power rule. So next thing is called derivative of product rule. Okay, derivative product rule. So we talk about sum, now we are talking about product rule. So this is little tricky and this is little harder than the power rule. Okay, so let me write the definition and I will explain. Okay, before explaining the theorem, I will give you one example and then come to the definition. Okay, so imagine you have a function fx, like two functions together. Let me write it like x plus 1 times x to the power 2. Okay, so it's like a product. Okay, it's like a product. So you have one product here, another product here. Two things multiply each other. I need to teach you how to get the derivative of this function, which is f dash x, quickly. Okay, quickly how you can get it. But if you think about this little bit more, I can simplify the brackets. You see, let me simplify the bracket. X to the power 3, and you multiply with this one, you get x to the power 2. Yeah, I just remove the brackets, and then I can take the derivative because you know the power rule. You can use the power rule for this, and you get 3x to the power 2, 2x. Okay, so that will be your final answer. But the question here, or the problem here, is you always need to simplify your brackets and write it as so many sums. So you may think, okay, this is very easy, it's not a big problem to multi-product these two. But imagine when you do a lot of hard questions, so many terms you will get plus, 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 and so on. Okay, so it's very hard and overwhelming. You get so many terms in your product. So how do we quickly do this differentiation without simplifying brackets or without product each other? So that's where the product rule comes. Okay, so when you use the product rule, this is how you do. So if you want to take the derivative quickly, you look at this guy. You see the first derivative. You write it as it is. Just write it as it is, and take the derivative of. Let me use a different color. Take the derivative of the other one. First write first product as it is, and just take the derivative of the second one, which is 2x, and then you take the derivative of the first one, first product, which is, if you take the derivative of x plus 1, what you will get? What is the derivative of x plus 1? Can anyone tell me what is the derivative? I can just write x plus 1 dash. What is the derivative of x plus 1? What is the derivative of x? Just 1, right? What is the derivative of 1? 0.
0.
Yeah, so the derivative of x plus 1 is what? 1. Agree? Is it clear?
Yeah.
Right. What is the derivative? Okay, you got the derivative of x plus 1, and you write the derivative, the other one you write as it is. Okay, so first, so let me erase this whole thing and I explain quickly. So first, remember what we did was, we keep the first guy as it is. In here we keep the first guy and take the derivative of the second one. in the next term, I take the derivative of this and keep the other guy as it is. So which I call derivative one term at a time, one product at a time, and keep the other one as it is. So if you simplify this, you will see you get 2x to the power 2, which is you multiply this with this, and 2x with 1 is just 2x, and you get x to the power 2 here. So finally you will see you get the same answer which you get using the power rule. See, but this method is more convenient and more powerful than the just remove the brackets and do one by one. It's a lot of time consuming and it's really hard. Okay, so let me explain the definition. If u and v are differentiable, you can say differentiable because you can differentiate. Differentiable at x, which means you can differentiate this function at x, then so the product, so is the product, so is their product uv, and the derivative of uv. So if you have a product, how do you take the derivative? Remember, you keep the first guy as it is, take the derivative of the other one. Remember, I use this symbol d over dx and f dash interchangeably. Okay, so sometimes I use d over dx for the derivative, sometimes I use just f dash for the derivative. So it's just, you can use whatever you like, because the book and your homework, they use the both. So that's why I want to teach you both. Okay, so you keep u as it is, take the derivative of v, and what is the next one? You keep v as it is and take the derivative of the other one. So this is not difficult to remember. Okay, so it's not difficult to remember, because if you have a product, you take the, you keep one thing as it is, take the derivative of the other, and you switch next time. Okay, you switch the other time. So you don't take the derivative of a one part both times. So you just take the derivative of a one product at a time. Okay, so let me do more tricky and hard question, and I will let you try this. This is question number, example number 2. So I take this time my function as a y. You know, I can choose fx and y, which is the same thing, right? So I'm gonna teach you more notations, more details. Okay, so I take the derivative function. The first product is x to the power 2 plus 1. My second product, x to the power 3 plus 3. So I need to take the derivative of y. So I can write d over dx is my symbol for derivative. I need to take the derivative of y, so I put y here. So which means I should apply this definition. So think this is your u is this, and your v, so this is your u and this is your v. Can you try this and tell me what you get? Okay, take a moment. I will give you like a 1 minute and we can try. Okay, Pedro or AJ, any one of you would like to share what you got? So first, what is the first part you wrote? So remember, I label my first part as u and the second part as v. Okay, so this is the definition. Can you tell me what is the first part should be? Pedro, can you tell me what is the first part? What should I write the first?
I'm
Right?
a bit confused, but would it be 3x squared?
You see, remember here, so let me explain again, okay? So I have a two product, agree? So I have one product here, another product. So my first product I label as a U. My second product I label as V, okay? That's my U and V. So here you can see U and V. The product is exactly my U and V is here. So the theorems or the product rule says, first write the first guy. So you have to write the function U first. Okay, I write it. And then take the derivative of V. Agree? Okay, take the derivative of V. This one. What you will get? 3x2. All right. Okay. So what is the next one? Can Pedro tell me what is the next one? What should I write next? This part. Okay. Think about this portion.
So you write x to the power of 3 plus 3.
Very good. And then I have to multiply it with what?
2x.
2x. Very good. Why 2x? It's the derivative of u. The derivative of u is 2x. Is it clear? So that's how you, that's how you differentiate. That is exactly the derivative of, let me erase everything. That is the derivative of this product. So normally, even in the exam or when you do application problem in your engineering, in your major, you don't need to simplify a lot of, once you get the derivative, you don't need the derivative simplification unless they ask you to do it. So this is just the derivative. So you have a function, you take the derivative. So this rule, you know, the one I wrote here, tells you how to work with the product, okay, rather than just multiplying everything and do it. So if you think about multiplying this with this, this with this, and so on, and use the power rule, it's a lot of work. Okay, so this is like a shortcut.
Why couldn't I just take the derivative straight up, like 3x squared multiplied by 2x?
No, it's not work. So that's why, okay, let me explain why it's not work. Okay, so you agree. So if I start with here, okay, if I start with here, I simplify and get, you know, I simplified here. Is it clear, AJ?
Yeah.
I simplified, okay, and I found the derivative. This is the derivative, okay. So derivative is not like you can just take the derivative for one thing and other thing when you have a product. When you have a plus, your argument is correct. When you have a plus, yes, you can take the derivative of this, which is this, and take the derivative of this and take the other one. You can do that if you have a plus, okay. So let's assume if I do your way of taking the derivative of this guy, which is just 1, taking the derivative of this guy is just 2x. Is it equal to this guy? No, right? You are missing, right? You are missing some part. Is it clear, AJ, my argument?
Yeah.
So if you have a plus, you can separately differentiate. But if you have a product, you cannot differentiate first guy and second guy and multiply. It will give you a wrong answer. So that's why we have this rule. This rule says do not do not take the derivative of u and derivative of v and multiply. Take a, just keep one thing as it is and take the derivative of the other, and you take the, the one you didn't differentiate, you have to differentiate the next time. So each time you differentiate one part at a time. Okay, that's how the rule works. Okay, so if you just take the derivative, it's not work. So you can see a lot of, hundred of example which is not your claim not gonna wrong, because of the, it's called a linearity of the differentiation. I'm not going to address so many hard concepts right now, but product rule is the one you're going to use when you have products. Okay, right. So the next part is the quotient rule. Since we have, quotient rule mean I will teach you. Okay, you know product. So this is the preview for the next class. Okay, Friday class. If you have a, let's say, x to the power 3, 2x plus 1 divide by x to the power 2 plus 6. If you have a quotient, how you do that? Is it as AJ claimed? Is it just take the derivative of the first guy and take the derivative of the second guy? Is this work or not? If it's turned out to be, this is not work. Okay, you cannot just take the first the numerator and denominator, take the derivative and get the the total. So it's not work. It's fairly complicated, and we will see it on Friday. So as a last example, I will give you let's say y. This is like a product example. So let's say you have 6x to the power 3 plus 4x times, this is like a product. I will put x to the power 5. I need to take the derivative, which I call dy over dx. If you are, since this is first time you heard about the derivative rule, you can always use the, label this as your u and this is v, and just write the differentiation rule, du, and you take the derivative of the other guy. V, you take the derivative of the other guy. Okay, so some people like to remember it like this: u times the derivative of v, which is v dash, plus v times the derivative of u. So this is much easy to remember because you put a dash. You take u and the other guy is dash in this case. Here you switch the dash. Okay. So now I will write it. U is what? 6x3, 4x. Yeah, I just write it as it is, u. And I need to take the derivative of the other one, which is x5. It's from the power rule, 5x4. Okay, 5x4. Okay, I'm done with the first part, but I'm not done yet. Okay, I have to add something. What is that? Okay, Pedro, tell me what should be the next bracket. Can you tell me what I have here? V, right?
What?
It's just V. V mean what?
Yeah, v is x to the power 5.
5. Okay. AJ, tell me what is the next one? U dash. Okay.
12x squared plus.
Wait a minute.
Yeah.
You're gonna differentiate this, isn't it? Are you clear? Are you sure about that? Is it clear that I want to take the
18x
18?
squared?
Very good.
18x squared plus 0.
Plus, wait a minute, not 0, because you have x included here.
Oh, so it's 1.
X is 1, but 4 is remaining. It's like a 4
so
times
it's 4.
1. It's 4. Very good. I think you two got the point, idea. Okay, so you two got the idea. Since the product rule, power rule, very new to you, get practice with. I posted the homework. You can start working on that. It's not due till Sunday. So on Friday class in person, we will discuss about quotient rule and much more example from the product and power rules. Okay, so we'll continue from Friday class. Thank you.
Do you have time to answer a quick question about last week's homework?
Yes.
I was confused about when limits just equal either infinity or negative infinity, because I thought I was supposed to get a value.
Yes. So you see, sometime there are situations, yeah. So I discussed this in the class. I will quickly remind you. If you have further problems, you can directly meet me maybe Friday after the class or Friday. Do you have time Friday at 3 p.m.?
Yeah, that should work.
Okay, so you can come to my office, KLC 126. You can write down this number somewhere.
Okay.
This is my room. My office hours 3 to 4. You can stop. I will discuss more about that. Since you miss a couple of classes, I went through those, how the limits become infinity, minus infinity. You asking the limit. Okay, so your argument is correct. Let's say when x goes to 1, I need to find the limit of 2x. Let's say you just plug it, right? You just plug it and get the limit. Yeah, it's a finite value. Yeah, it's get a finite value. How about if I ask you this, 2 over x when x goes to infinity, or let's say when x goes to 0. So this is the idea here, AJ. So let's say x goes to 0 mean I put very small value for my x. So let me put a very small value for x, 0.1. Okay, if you put 0.1, you will get 20. Okay, you will get 20. So I need to send my x to 0. Okay, so that means I need to divide my 2 by very small number. If I divide by 0.01, I will get 200. If I divide by even smaller number, because I need to tens or approach my x to 0. So if I make my x even smaller, I get final answer bigger and bigger. Can you see that?
Yeah.
Yeah. So what happened? My division, my denominator become exactly 0. If I reach to 0, my final answer goes to infinity. You understand the concept?
Okay.
Okay, so your answer getting larger and larger and larger, and eventually it's reached to infinity. So that's how you get the infinity.
Got it.
So
I understand.
you understand. Okay, so same to the minus work. Okay, so if you have a minus something, let's say the same thing with the minus, it goes to minus infinity. Okay, because if you are getting very smaller number each time. Okay. So, yeah, so we will discuss more details, and you are missing classes. If you have any homework which I really need to reopen, you can meet me on Friday 3 p.m. and we will discuss about your issues, your questions, your concerns, and everything. Okay.
All right.
See you Friday in the class, and we'll meet at 3. Okay.
All right. See you tomorrow.
I posted the practice test as well. You should be able to see it on Canvas. Okay, so just take a copy of it and start working on it.
Got it.
Okay.
All right.
See
Have a
you.
good day.
You too. Bye.